Hi everyone, I'm Mario and welcome to Code on Fire. This time we're going to talk about object-oriented programming, explaining what it is in the simplest way possible. We'll discover how programming is literally building objects inside a virtual factory. We will transform code into tangible 3D objects. We'll build the pieces of a user interface from scratch, and you'll see exactly step by step what happens inside the computer. A small but fundamental premise. For this video we'll use C# because it's very clean and an absolute industry standard. But pay attention, the concepts you are about to see are universal. Whether you're studying Python, Java, C++ or TypeScript, the logic and architecture don't change. Learn this today and you'll have learned object-oriented programming forever. Let's begin. Everything in the object-oriented programming starts with an idea. In the world of code, this idea is called class. Look at this code on the screen. When we write a public class UI component, we are literally creating a blueprint, a mold. We are telling the computer, this is the base architectural blueprint for an element of our interface. We define that it will have a color, a label, and that it can be interacted with. But look closely at the 3D mold we just generated. It's empty. If you were the end user, you could never click this mold. It doesn't exist yet as a physical object in the computer's memory. It's just a concept. This is the first big mistake beginners make, confusing the class with the final object. The class is like a cake recipe. It tells you how to make it, but you can't eat a recipe. To get our real button, we have to turn on the machinery and manufacture it. And here's the magic. To go from theory to practice, we use one of the most important words in all of programming, the new keyword. When we write a new UI component, we are powering up our mold. We are ordering the computer to take that empty blueprint and allocate a real space in memory to physically build it. This exact manufacturing process is called instantiation. It literally means to create an instance, and the result of this manufacturing is finally here, the object. Now we no longer have an abstract idea. We have a button 1 and button 2. They are two solid, real objects ready to be used on the screen. And notice one fundamental thing. They were born from the exact same mold, but now they are two completely separate and independent entities. Having been created from the same base blueprint, our two buttons are currently identical clones, but in a real app, every button has a different purpose. We need to give them an identity. To do this, we use attributes, which we often call variables. Attributes are the data that describe our object. They are its adjectives. By assigning the red color and the text login to one button, we make it unique. We do the same with the other, making it blue. Same starting class, but completely different data. However, an interface shouldn't just be a pretty picture. It has to work. Objects know how to perform actions, and these actions are called methods or functions. Methods are the verbs of programming. When we call button 1 interact in the code, we are giving a precise order. The object hears the call and reacts by performing the task it was programmed for. In this case, it pushes down and sends a signal. Now that our button works, we need to talk about security. And here comes into play another fundamental pillar, encapsulation. Imagine your TV. To turn it on, you use a simple button on the remote. You are not required to open the back panel to connect the wires by hand. In code, the same rule applies. Inside our button, there are very complex variables and logic. Maybe there's a counter tracking how many times it was pressed, or a function that performs a calculation. Encapsulation allows us to hide all this complexity. By using the private keyword, we literally lock this sensitive data inside the box. The rest of the program can't see them and, above all, can't accidentally modify them. The only thing we leave open to the outside world is our public interface, marked by the public keyword, like the interact method. They only offer the user a safe way to use the object, and the object handles its internal chaos in total autonomy. We are ready to close the circle by talking about polymorphism, which simply means having many forms. Now we don't just have a button, we also have a checkbox and a slider. They are visually different elements, yet thanks to OOP, we can group them and control them with a single command. How do we do this in code? First, we tell our base class UI component that its action can be modified. We do this by adding the virtual keyword to the interact method. It's like saying this is the base action, but I give permission to different objects to do in their own way. Now we create our three specific classes: button, checkbox, and slider. They all inherit from the mother mode, but they use a new keyword, override. It means override. The button says I use override to say that when they call me, I push down. The checkbox uses override to say I make a checkmark appear. Each has its own internal intelligence. And here is the real magic. We put our three physical objects into a single list. Now we create a loop that goes through each element in the list and issues a single generic command to all of them: component.interact. Look what happens. The button receives the command and pushes down. The checkbox receives the exact same command and makes the checkmark appear. The slider hears the command and slides. We don't have to worry about specifying the action for each one. The object knows perfectly well who it is and how it should react. Think about the power of this in the real world. If you're building a smart home app, you can give 50 different devices, like lights, the turn off command, and each one will turn off in its own way. One single order, hundreds of different reactions. This is polymorphism, and it's what makes your code scalable. Object-oriented programming is literally building logical blocks that collaborate with each other. You design the mold, you build the physical object, you protect it by looking up the delicate part, and you teach it how to behave. That's all. Thanks for watching. Subscribe to the channel.